This is the Chem 1 lecture over salt hydrolysis. So we've talked about this a little on the first day, but salt hydrolysis is the idea that when you form a salt, you form it, I don't know where to put this so it shows, there we go, from the cation of a base and the anion of an acid. So you're talking about that hydrogen ion acceptor from the water. So what does it mean? It means that you can determine if a salt is neutral, acidic, or basic by looking at what parent acid and base it was formed from. So I might have just explained that weird, but it's all going to make sense in about 2 seconds. So let's look at an acid-base reaction. If you take an acid and react it with a base, and acids always start with hydrogens. So since a hydrogen's positive, the other half of the acid is a negative anion. Base is always in an OH for the Arrhenius definition. That's what we're going to stick with on this one. And so the other half of a base is always a positive cation. And when they react together, the cation and the anion come together to form the salt, and the H and the OH come together to form water. Well, because we know that the anion came from the acid and the base has the cation, you can always predict what the parent acid and base were. And we did a little bit of this, and hopefully you guys remember. So acids always start with hydrogen. Is this positively charged hydrogen going to be attracted to the positively charged Na or the negatively charged Cl? So it's going to go with the negatively charged chlorine, and I re-crisscross it every time because we're talking about ions. Base is always in a negative OH. So who is that one going to be attracted to, the positive Na or the negative Cl? Positive Na, which has a +1 charge, and I can re-crisscross that. NaOH. So do the same thing here, and your acids are always going to start with hydrogens. Your bases are always going to end with OHs. So who does this positive hydrogen go with, the NH4 or the Cl? The Cl, just like before. Then you crisscross it. And so the NH4 is obviously going to go with the OH. Do I bring that little 4 with me? Yes, because it's not how many, or it is how many, but it's not a subscript that I wrote. It's part of that polyatomic. NH4 is ammonium, and it's always, always, always NH4. You can never change that. NH4 has a charge of +1, so then I re-crisscross it there as well. So you can determine the acid and the base that the salt comes from. Now, because the salt is made from an acid and a base, it can change the pH. Remember, your reds are your blanks. And because you can change the pH and you know what that acid and that base are, you can predict whether the salt will change the pH to make it above 7, which is a base, below 7, which is an acid, or at 7, which is neutral. So I like to think of this like a wrestling match. Do we have all these written? If it's a weak acid and a strong base and they're fighting, who's going to win? The strong base is going to win, and so your resulting salt will be a little bit basic. It's going to have a pH greater than 7. If you have a strong acid wrestling with a weak base, who's going to win? The strong acid. So your resulting salt is going to be a little bit acidic, and you're going to have a pH of less than 7. What if it's a strong acid and a strong base? It's a tie, exactly. No one's going to win, and so you're going to have equal amounts of acid and base, so your pH will be 7. What about weak acid, weak base? Who's going to win that? We don't know, and I told you we're not going to really focus too much on weak acids and weak bases, but you will never, ever, 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 ever have a problem where the answer is weak, weak. If you come up and you're solving a problem and you get the answer to be weak, weak, you did something wrong. I'm perfect. I didn't make any mistakes. It was obviously you. I'm just teasing about that. I make mistakes all the time. But you're never going to get a weak, weak answer. So if you do, rethink it. Make sense? So let's do a couple examples. Here's our salt, SrCl2. We need to figure out what the acid that it came from was and what the base was. Acids always start with hydrogens. Bases always start with or end with OHs. So who's going to be attracted to that positive H plus out of my SrCl2? Cl2. Now, do I write Cl2? No, I just bring down the ion. This 2 is only there because the Cl is specifically with the Sr. When you're talking about ions, you re-crisscross every time. So that ends up being +1, -1, and you don't have any numbers there. Over here, who's going to be attracted to that OH? The Sr. Sr is in group 2 on the periodic table. So what charge does it have? +2. So I have to re-crisscross Bring the 2 down over here. And remember, OH is a polyatomic, so it does need those parentheses. Now you're probably looking, you're going, this isn't balanced at all. I only have 1 chlorine, I have 2 chlorines, I have 2 OHs, so on and so forth. The only reason it does not look balanced is because it's not written out as a balanced chemical equation with all the pieces and so on and so forth. So don't worry about having unequal numbers of things in this. You just re-crisscross every time. The purpose is to figure out what the acid and the base originally were. So if we wanted to, we could write the whole chemical equation and balance it, and I promise it'll work out fine. Now your next step is to determine what you got. Who's wrestling? A strong, a weak, a strong? What do you got? Is HCl a strong or weak acid? Strong. And you have to memorize these. HCl, HBr, HI, and any acid that has 2 more oxygens than hydrogen is strong. Every other acid is weak. What about SROH2? Is it a strong or weak base? It's strong base. Your strong bases are anything in group 1 with an OH or BA and SR. Those are the only 2 that aren't in group 1 that also are strong. And this happens to be SR. So if we have a strong acid and a strong base, what's my resulting pH going to be? It's going to be 7. And that's what it is. I put that pH meter right into that solution and I tested it. Sure enough, it came out to be a pH of 7. It doesn't matter. If they both completely break apart, all the H's and the OH's that break off are going to find each other to make water, and water is a neutral substance. Whereas if the acid's strong and the base is weak, all the acid hydrogens are going to break off, but not all the OH's of the base are. So you're going to have excess number of H pluses, which means your pH drops. Your H plus concentration increases, which in turn, the negative log makes the pH. Does that make sense? Let's do another example, and then that's all I got for you. So here's the next example. NH4NO3, we've got to find the acid and the base that it came from. Acids always start with hydrogen. Bases always end with OH. Which part of this is going to be attracted to that positive hydrogen? The NO3. And do I bring the 3 in this case? Because, I didn't bring the 2 last time. Why do I bring the 3? Because it's a polyatomic. NO3 always sticks together. It's got a -1 charge. So he's already crisscrossed. HNO3, strong or weak? By our definition of strong or weak acid. It's strong. It's got 3 oxygens and only 1 hydrogen. So there's at least 2 more oxygens. Just practice. I promise. It'll come to you. What's my base going to be? What's going to be attracted to that negative OH? NH4, and I'm bringing that 4 again because it is a polyatomic. This is a +1 charge, so I crisscross. Is NH4OH strong or weak? Weak. Very weak. So my acid's going to win this war. When we fight, acids are going to win. So my resulting pH, my salt is acidic, so the pH is going to be less than 7. You guys are amazing. You have an entire chart to fill out on the back. Your homework last night that looked like a chart? Your test has a chart just like that on your test that you fill in, just like last night. Your test also has a chart that looks just like this homework that you have to fill in. So